Hi, welcome on Things to Consider. Today we're going to consider all the factors that you have to look at in choosing an effective engineered compressed air blow-off nozzle. First of all, safety. You want to make sure that the nozzle is an OSHA standard nozzle. That means that the dead end pressure on that nozzle at full pressure is going to be under 30 psi coming out. So if you have 80 pounds going to that nozzle, you want to be able to put your hand at the end of that thing and the pressure is going to be under 30 psi. That meets the OSHA standard. Secondly, noise. A well-designed engineered nozzle is going to reduce the noise dramatically as compared to an open pipe or a non-engineered nozzle, for example, because one of the factors of that you really want to use an engineered nozzle for is to reduce factor noise, to reduce the noise in an application. Third thing, distance to the target. Now, one of the nice things about a Coanda design engineered nozzle, for example, is that you have a laminar flow over a distance. So the distance to the target is going to matter because some nozzles have a wider angle of airflow, some has a more narrow angle. A more narrow angle is going to concentrate the force. So you want to know the distance from the nozzle to the target to see how effective that force is going to be, how much it spreads out. You'll have a total force that might be the same at this distance to that distance, but it's going to spread out more the further you are from the target. So you want to know how much the distance is so that you get the adequate concentration of force. And engineered nozzles will usually have flow patterns published to be able to determine that. You want to know the total force that is needed at the target, or the total flow. Cone-shaped nozzles are certainly used still extensively. They're excellent for flow amplification, especially. Engineered nozzles of this kind of design are ideal because you get a very high force per CFM ratio. So for part ejection, for pure blow-off, where force is important, these types of nozzles are usually better. But you need the total force at the particular target at the distance that you've pre-selected. And finally, adequate line size for the air consumed. Now, let's say you've done all the other stuff. You know exactly where it's got to be, you know the force you need. You look up in the chart and you see that when you have 80 pounds force going, or 80 pounds pressure rather, going into the nozzle, you get X amount of force at this distance at this type of flow pattern. That's fine. And you get, say, 2 different nozzles to test from 2 different manufacturers. Both manufacturers indicate that you get at 80 psi at the nozzle, you will get X force at X distance. That's fine. You hook up the nozzle to your line, and let's say it's a 1/4 inch nozzle, you would naturally put it on a 1/4 inch line. And you test the nozzle. And for some reason, one nozzle isn't performing exactly the same as the other nozzle because of something. What? Well, let's say we have 2 nozzles from 2 different manufacturers, both rated to give you X amount of force at X distance at 80 psi going into the nozzle. But one nozzle is going to use even a little bit more SCFM. If that line, that 1/4 inch line that 1/4 inch nozzle is connected to is very long or has a lot of bends, you're going to have pressure drop in that line. So that the actual force the actual pressure entering that nozzle is not necessarily going to be 80 psi, you're going to have pressure drop. And the reason you're going to have more pressure drop in the nozzle that uses slightly more SCFM is simply because of extra flow. So the longer that 1/4 inch line is, the more pressure drop you're going to have. So if you put the 2 nozzles, even though they're rated for the same force, at the same distance, at the same pressure in the nozzle, you're not going to have the same pressure entering that nozzle if one nozzle is using more air than the other nozzle. So you have to really look at the actual CFM that the nozzle is consuming. So again, in summary, in choosing an effective compressed air nozzle, you have to consider the safety. Is it meeting the OSHA standard? Does it reduce the noise? the distance from the nozzle to the target, the force needed at the target at the distance you've chosen, and make sure that the line size is adequately sized for the air that's being consumed.